So we're looking at analytic description of periodic function under Fourier series. Now, a periodic function can be defined analytically in many cases. All right, we said a periodic function is one that repeats itself. So it can also be defined analytically in many cases, a periodic function. So let's look at this first example. Of course, this is your x-axis, this is your y-axis. This is also your f of x axis. Now, this is 0, 4, 6, 10, 12, and this is just 3 here. Now, don't forget we said that a period is a complete circle or cycle. A period is a complete cycle. That means how long it takes for one circle to be completed. And if you look at it, starts from here, right? The waveform starts from here, down here, and then it ends here. And then you see another one starts here again. Another one starts from this point again. You see this other one starting again and then ends here again. So if you look at it very well, you see that from here to here is a period. Coming from here again down to here is another period. And that's how it keeps going. So we want to analyze this periodic function. So how do we do that? Now, first off, we're going to analyze this. So between 0 and 4, right? Between 0 and 4, y is what? 3. Between 0 and 4, look at it starts reading and then moves like this. So between 0 and 4, between x is equal to 0 and 4, y is 3. So we say between x is equal to 0 and x is equal to what? To 4, y is equal to what? 3. Which implies that what? Which implies that f of x is equal to what? 3. And also is going to be from the range of what? 0 is less than x is less than 4. Between 0 and 4. Alright? Between what? 0 and 4. So between x is equal to 0 and x is equal to 4, y is equal to 3. Now, let's go further to analyze more. Now we've analyzed between 0 and 4. Let's analyze between 4 and 6. Don't forget, this is a whole full cycle. So we don't just analyze it, we also analyze from here to here. So between x is equal to 4 and x is equal to 6, between x is equal to 4 and x is equal to 6, between x is equal to 4 and x is equal to 6, what is our y? Now look at this is 4 and 6. Look at this waveform starts from here and then comes down here. So between 4 and 6, our y is 0. Between 4 and 6, what? Our y is equal to what? 0. That implies that what? F of x is equal to what? F of x is equal to 0 between the values of what? 4 is less than x is less than 6. Now, that means we're going to write it now in a more arranged form. It's going to become that f of x is going to be equal to this. So we're going to say that when our f of x is 3, it's going to be between the values of 0 is less than x is less than 4. And when our f of x is 0, that's here, it's going to be between what? 4 is less than x is less than 6. Alright? So this is going to be our f of x. Then now, we're going to also add the period. The period is how long it takes for it to complete a cycle. How long it takes for it to complete one cycle. Right? Complete one cycle. So now, it starts from here and then comes here and then ends here. And then another one starts again and reads like that. So how long from here to here is how long? That is what? 6. Alright? It takes 6, let's say 6 seconds or 6 milliseconds or 6 units all right, to complete one cycle. So our period, of course, is 6. So it means that our f of x, all right, can also be written as what? F of x plus 6. All right, that's this is representing our period. All right, since our period is 6, you can also write it as this, or some people write it as f of x plus 6 is equal to f of x. All right, so this is an analytic description of this particular periodic function. All right, now let's go to this other example to analyze this. Now, this is a periodic function. You can see it starts from here, moves like this, moves like this, moves like this. Now, we're going to notice that this starts from the origin. Don't forget, in physics, when we plot a graph or in any graph, when it starts reading from this point 0, we say that what it is starting at from the origin, which is 0, 0, right? So now it's the same thing here. This is starting from 0, both the x and the y axis. Starting from what? From 0. So it's starting from the origin. Now, here we're going to make use of the equation of a line to analyze this. Because some students have complained to me that they just see textbooks or maybe their lecturers just write one answer and they don't really know how they got it. Now, they use the equation of a line formula. All right. Now, what's the equation of a line? Equation of a line. The equation of a line formula. Right, let me rub this off. I'll still come back to this. The line formula is what? Y2 minus y1 over x2 minus x1 is equal to y minus y1 over x minus x1. All right. So please take note of this formula. We're going to be using it here. It's very, very important. We're going to be using it in this question. So, of course, this starts from an origin 0, 0, like I explained here. Let me draw this again, 0. So, it starts from the origin. It starts from the origin, which tells us that 0, 0. That means our x1, this is our x1, 0. This is also our what? Y1 is 0. All right. Now, so from the origin, we know that it's 0, 0. Of course, this is our x1 and then this is our y1. All right. Now let's go further. Now, so this is starting from the origin, like I said. Now, if you notice, all right, if you notice, when this is 0, 0, when x is 2, y is also 2. Look at, when x is 2, y is also 2. All right, if you notice that very well, when x is 2, apart from it starting from the original, you see that when x is 2, y is also 2. So we say when x is 2, y is also 2. So it becomes that we now have 2, 2. So this is our x2 and this is our y2. All right. So we're going to put this into this formula to find the equation. Don't forget I said this is the equation of a straight line. Equation of a straight line. Equation of a straight line. All right, this is the equation of a straight line. So now let's continue. So it becomes, putting all this into this formula, it becomes y2 minus y1, that's 2 minus 0 over x2 minus x1, that's 2 minus 0 is equal to y minus y1, that's y minus y1, 0 over x minus x1, which is what? Also 0. So 2 minus 0 gives us 1, then 2, sorry, over 2 minus 0 also gives us 2. So this is equal to y minus 0, of course, is y, over x minus 0 is x. 2 divided by 2 gives us 1 is equal to y over x. Cross multiply, we're going to have y is equal to x. So if you have y is equal to x, it means f of x is also equal to what? X. All right. So this is for the first case. All right, this is for what? For the first case. So between x is from 0 to 2, we have our f of x to be equal to x. But just know that it starts from the origin, which is 0, 0, and then you find out that when x is 2, y is also 2. So we use that information to find the equation of the line between here and here. So between from x is equal to 0 to x is equal to 2, we have what? F of x is equal to x. Now, let's go further to analyze. Now, we're not just going to analyze from here to here. Don't forget that a period is a complete cycle. So from here to here is a complete cycle. From here to here is a complete cycle. So let's go further to do that. Now, we'll notice something that what? When x is what? 6, or let's say, yes, when we'll still use this information. We use from here to here. Now we're going to go further to use from here to here. We just use here to here to make this description, this analysis. So now we're going to go further to use here to here to make the next analysis. Now we cannot point this to anything. That's why we're not using this for. But we can point this, all right, to something here, all right. See it here. So we have used 0 between 0 and 2. Now we're going to use between 2 and 6. So now, so we know that what? We know that when x is 2, y is also 2. When x is equal to 2, y is also equal to what? 2. All right. Then now that gives us what? 2, 2. So this is like our x1, is our y1. Now you see it very clearly here that when x is 6, y is 0. When x is 6, trace it, see, y is 0. So when x is equal to 6, y is equal to 0. So we have 6, 0. So this is our what? X2, and then this is our y2. All right. Now let's use the equation of our line of the line formula to get the f of x. So now what's going to happen here? We're going to apply this formula. So y2 minus y1, y2 0 minus y1 2 over x2, what is x2 here, minus what? X1, that's 2, is equal to what? Y minus y1, that's 2, over x minus x1 minus x1, that is minus 2. All right. So 0 minus 2, that gives us minus 2, over 6 minus 2, that gives us what? 4. So that's equal to what? Y minus 2 over x minus 2. Now, reduce this to lowest, it becomes minus 1 over 2 is equal to y minus 2 over x minus 2. All right. So now we're going to cross multiply. All right. So it becomes 2 multiplies this. We have 2 into bracket y minus 2 is equal to minus 1 into bracket x minus 2. All right. Now let's continue from here. All right. Let's continue from here. I hope you've written this and you understand this. But let's continue from here. Let's take this off. Let's take this off. So now let's continue. So it becomes that what? F of x is going to be equal to what now? Okay. Oh, so it becomes, we have not simplified this. We're not done with simplifying this. So let's simplify this. So 2 times y, that gives us what? 2y. 2 times minus 2, that gives us minus 4 is equal to minus 1 times x gives us minus x. Minus 1 times minus 2 gives us what? Plus 2. All right. So take this here. You have 2y is equal to minus x plus 2 plus 4. All right. So this gives us what? 2y is equal to minus x plus 6. Now we divide through by 2. We're going to have y is equal to minus x divided by 2 plus 6 divided by 2. And then this gives us y is equal to minus x plus 6 divided by 2 is 3. All right. And don't forget your over 2 here. So it also means that f of x is equal to what? Minus x over 2 plus 3. So between 0 and 2, our f of x is equal to x. And between 0 and 6, our f of x is equal to minus x over 2 plus 3. So bringing them together now, it means that our f of x is going to be equal to what? It's going to be equal to what? The first one, we have x from what? From 0 to 2. All right. Then the next one, we have what? Minus x over 2 plus 3 from what? 2, between 2 and what? 6. All right. So this is our analysis. This is the analytic description of this period given to us, of this waveform given to us. So this is how you analyze it. Now, of course, we have to also put the information of the period. I said a period is one complete cycle. So it starts from here, from the origin, like we said here, and moves here, then moves here, and starts again like that. So how long does it take for it to complete this from here to here? It takes what? Let's say 6 units, 6 seconds, or 6 whatever. It could be any units, it could be seconds, it could be milliseconds, like I said earlier. So the period, of course, the period is equal to 6. The period is equal to 6. So meaning that we can write it as what? F of what? X plus 6 is equal to what? F of x. Alright? F of x plus 6 is equal to F of x. So this is how to make the analytic description of this waveform, or of this periodic function, and of this periodic function. So we're going to go ahead and look at some more examples. So we're going to go ahead and look at some more examples in the next video. So make sure you click the link to watch the next video, or make sure you check the playlist to watch the next video.